the session is being recorded. As per Papaya Act, we need to inform you that the session is being recorded.
Right, so we're now at 18. I guess we could just start. So I'll just start with welcoming, and I'm sure a few more people will still join. But yes, so thank you so much, everyone that's dialed in. It's good to see also some familiar faces and names dialing in. Today we have SIBA Industries who will be introduced shortly by Dion, who they are, what they do, and they'll be presenting to us and showcasing to us one of the process intelligence tools or technologies that are available out there in the industry, which is Apromo by Salesforce. Yeah, so we already asked you during your registration if you have any questions, and some of your questions will be answered during the course of the presentation. We won't go through each question one by one, so just pay attention and maybe your question is answered through the presentation. But if there's anything else that you still feel is not answered, feel free to drop it in the chat. And yeah, the colleagues from SIBA Industries, I hope I'm saying it right, will also address that. And yes, like I said, if feel free to keep your video on, but please keep your microphone on mute so that we don't have much disturbances and background noise. So now I'll hand over then to Dion. We'll also have at the end some bit of time for Q&A as well. So not to worry if you feel you really need to say something, and yeah, then you can also catch the Q&A at the end. So over to you, Dion.
Thank you very much. So hi, everyone. My name is Dion Bacchus. I work as a data scientist at SIBA Industries with my colleagues Fiso and Charlie, and we're going to present to you what we have built as our process intelligence function, which really feeds into the main business of SIBA Industries, which is providing workforce and RPA solutions for clients. So who is SIBA? SIBA Industries is basically what we refer to ourselves as the premier specialist, providing integrated AI process intelligence, as well as workforce and RPA solutions to clients globally. We adopt an approach that tries to consider the cross-functionality between technology and people. So for all the AI kind of stuff that we're working on, we adhere very strongly to human in the loop. That's just a little bit of background. Onto the process intelligence. There we go. So to introduce this idea of process intelligence, I just want to set the stage. We are living in a time of the rise of data-driven management. The world has been going through a massive shift since the birth of the internet and all these kinds of things. And systems, customer-facing systems, client-facing systems, B2B systems, all of these systems have become a lot more complex. And with that complexity comes advantages and gains, but also additional challenges. So the idea of data-driven management is so that we can see what is actually happening on the ground, and then we can test those changes in a data environment with simulation, and then we can make business management decisions based on what we call comparative return on investment. But essentially, it's the idea of pre-testing or simulation testing your solutions. And why now? Because, as I mentioned, we are in an era of digital transformation, and just as a city needs to have a sort of bird's eye view of how it functions and how it processes various packets of information, we need to have the same thing built into businesses. So to introduce Apromo, Apromo is a flexible simulation-focused process mining suite. I say simulation focused because it really is geared towards simulation as a capability, with generally, compared to the rest of the market, somewhat more sophisticated simulation parameters. For example, where Apromo beats out a lot of the competitors in simulation is that it includes parameters for per activity time distributions. You can even set things like performance handicaps per role. And the simulation is role-based simulation. So essentially builds tables of task responsibility for a given resource grouped by into a role. There's lots of deployment strategies, including on-premises, cloud, and those kinds of things, which is going to change in the future with the Salesforce integration. And in general, the business areas of impact, Salesforce has a strong leaning towards compliance and auditability. You know, making processes visible is one step away from making them auditable. Performance management is included in there, KPI monitoring, and then the focus of today's demo is really explaining, showing how Apremore and process mining can be used in a comparative return on investment context with a method that we use at Cibo, which I like to call diagnose and simulate. So essentially we look for problems and then we simulate potential solutions and pick out the best one. So Apremore itself, as I mentioned, has recently been acquired by Salesforce for integration into their systems. And Apremore, for the years leading up to the Salesforce acquisition, has been winning a handful of these awards from the Gartner and Data Breakthrough Awards societies. So that's a little feather in their cap to note. So onto the conceptual foundations. Really, I want to break this up into two main groups of thinking, two main categories. The first is process mining. Process mining is probably a lot more familiar to some of the audience, where we will take data from a system. I like to call it system footprints, and we produce these end-to-end process maps based on the actual processing rather than some kind of idealized path. And then we can overlay information like time, cost, and compliance with various KPIs or SLAs onto each process path. So that's really the investigation phase, the diagnosis phase. The next conceptual foundation, the next conceptual brick to consider is the simulation aspect. So this is what we call digital process twin simulation. And this is where we create a living replica of the process operations, of your business processes operations. And we use that replica to query the predicted outcomes of process redesign changes. So essentially we create a what-if playground where we can predict things like process integrity or improvement return on investment under various kinds of interventions or different scenarios. We can also predict things like how will the process fare under high activity periods, or if there's staffing changes, that kind of thing. And these two fit neatly into a sort of continuous loop within the business process optimization field, where we first discover what the process reveals, we then diagnose process issues, simulate potential changes, implement the best of those, and then monitor the implementation. We call that our version of round-trip process mining. Sorry, I can hear a little bit of interference on a mic. Just please make sure that all of your mics are muted so that we don't catch any background noise. Thanks. So onto the one of the fundamental features of Apremore is it's got this data design which is founded on the single source of truth being the event log. Now, an event log is something produced by an ETL or by your integration with various CRM or ERP systems. Essentially, it's a spreadsheet which has data organized by cases. So it's case-wise data, as you can see in the little picture on the top right. You have activities performed by a specific role with lots of trailing attribute data, which you can include. But the main thing to understand is that we organize the information in terms of cases. So we group together all instances of a process, and we group that into essentially trace level data, which allows us to map the actual trodden path, kind of like footpaths in a forest. We can actually see where activity has actually flowed, where there's real bottlenecks, where there's real loops. And this is different from the traditional way of doing things in a business context where we would conduct interviews with staff, but people may miss on small details that data processing necessarily must capture. And then the additional benefit for this, or from this departure point, is that we have a simulation race-wise event log, which essentially it gives context to the activity. So the event log is all about the activities organized into cases with a whole set of context around those activities. One of the primary features of context would be the resource and the role information. So these are the agents, whether they be automated systems or humans themselves, that actually perform these various activities in a process. And so what we're trying to get to is this comparison, which has become Apromore's slogan for a number of years: expectation versus reality. So on the left, you can see a very basic process map for a ticketing process where the ticket is submitted and categorized, then gets assigned to an agent. There's either a technician resolution or a supervisor review. But one thing which failed to be captured in this idealized process conducted from or reconstructed from interviews is this idea of there's some tickets that are reopened. So this entire loop between agents where they reopen and close tickets amongst themselves is passed over. So the idea is we want to discover and make visible all of these hidden process routes which might exist because reality is messy. And I'm sure all of you who work in a data environment know exactly what I mean when I say that. The foundation of Apromore's processing is a mathematical formalization of graphs, which is called Petri nets. These essentially create a processing network where you'll have checkpoints that tokens will move through in a BPMN structure, and essentially the state of those tokens tracks which conditionals they've gone through, what kind of probabilities to simulate, and other kinds of assumptions about the process. So essentially, we like to use the metaphor that the Petri net or the BPMN is the plane and the simulation aspect is really the flight. So you would apply that plane, you would apply certain conditions to that plane, and you would then simulate conditions in a flight. And that's what we would call the what-if scenario. So that's where we use role-based simulation, which is essentially a table of system and user responsibilities made explicit, and use that information to predict what is the performance of the process given different flight conditions. So perhaps you might change the wind speed or something in the metaphor, but obviously we're talking about business processes, so wind speed is probably not a factor. And just to show you how complex it can get, this is some data which we will go through in a brief case study towards the end of the presentation. This is this is the actual digital twin. This is the BPMN structure that we can then modify various gateway probabilities. So essentially, these numbers on the right-hand side represent what is the probability of a token moving through this network. What is the probability it'll go to this node or that node, and all these kinds of things. So we use that information to reconstruct the process for the purposes of simulation. And this is all built into Apromore's backend. So Apromore has a very analyst and business executive focused build, where it's a low code environment. It really focuses on the statistics and the trends rather than trying to code out solutions. So a sample which I'll just demonstrate before we go to a more complicated case study. So the idea is we would lead the process mining investigation with diagnosis once we've done discovery, which is automated from the event log in Apromore. And Apromore makes it very easy to find where your bottlenecks and potential process issues may arise simply by using color coding and the thickness of arrows. So this is that same ticket support ticket case that I mentioned earlier. And here we have two distinct problems that we've found in the process. The first problem is that there's a significant delay when tickets get escalated to supervisors, about 3 hours on average. These waiting times between activities show averages. And secondly, another bottleneck exists in this process where when the ticket is assigned to a technician, there seems to be a serious delay in the technicians actually picking up that ticket to claim it as their own work. So this is based on synthetic data, and in this example, the technicians must assign themselves to cases, to tickets, as opposed to having them assigned by an agent. So the process is kind of, there's room for improvement, either with regards to perhaps automation or adding additional supervisors. So this is really where the simulation aspect, which we'll move to next, shines, because the idea we want to test which of these directions of improving the process is really going to give us the best return on investment. Is it an automation or is it a recruitment problem? And we want to base that decision on evidence. We want to base it on data. We don't want to base it on experience or somebody's opinion on something. So as I mentioned, there's two improvement options in these what-if scenarios. The one is adding an extra supervisor, and now you must understand, when we add an extra supervisor, because of the way task role responsibilities are assigned in Apremore, adding one extra supervisor will actually add an additional pair of hands to two separate tasks. Whereas the alternative solution, or an alternative solution, to automate the technician assignment with a bot, an RPA bot, only affects that given task. So this is something which is built into the back end of Apremore with the role-based simulation. So the idea is we want to then compare what would be the process effects and results downstream of either of these two what-if scenarios. And how we do this is we first simulate a baseline case. So we take the raw discovered, or we take the discovered event log, and we simulate a no change scenario, kind of like a null hypothesis. And then on top of that, we can simulate a plethora of to-be scenarios. And the to-be scenarios are the scenarios where we make one tiny change and see what the results are. And this is really where things get interesting, because if you want to do some extensive testing, you can make a lot more holistic to-be scenarios, or you can take a reductionist approach. So you can change one thing and see what the changes are, or you can change a handful of things. And this is one of the interesting applications of this system, is you often find that you may resolve one bottleneck, but then the delay just moves further downstream in the process, which means that you haven't actually resolved the bottleneck. You've found something which is covering up the bottleneck. So through a series of iterative to-be scenarios, and perhaps a holistic to-be scenario where you make a few changes at once, you can really resolve and find the cause of a bottleneck, even if it has a lot of upstream delays that are resulting from a backlog, essentially. Anyways, I digress. The results of this fictitious simulation. So first of all, we define the problem of process optimization, broadly speaking, in terms of two factors to optimize, and that is to reduce case duration, so to improve processing speed, and to reduce the costs applied to cases. So you can also attach role-based costing to your process model in Apremore. So in this example, the as-is baseline reproduced the same two process bottlenecks that we found in the raw event log. And when we apply the supervisor-based fix, so the recruitment-based fix, we can see that that delay reduces from 6 days in the baseline simulation to about 8 hours. Now there is a difference compared to the real data. That's a little technical for me to go into here, but if anybody does want to find out, you can ask. I'm more than happy to explain it. And that compared to the to-be simulation shows essentially when you apply the RPA fix to the assigned to technician activity, that also improves the case duration there. This is just a very simple way of showing what the simulation looks like. The real meat is where we compare them, which I'll go into a little bit later. So just to set the stage a little bit for the sort of business case for Apromore and process mining and digital twin simulation in general, some important prerequisites for success for any of these kinds of projects, integrations, is to have a very clear definition of what is the process that you are aiming to study. You got to know which data systems are involved. Is it transactional data? Is it other kinds of data? What ERPs? Are the data available with timestamps? And very importantly, is the data can it be organized into case identifiers? That's often one that trips projects up. The second thing to be very aware of is what are the business goals? So as I mentioned, we focus on reducing case processing time, so saving time and saving money. So those are the two business goals broadly speaking, but there's many ways to conceptualize this. An important consideration as well is process ownership and the context. So you need to have a bit of cross-functional collaboration across teams, between executives, between managers, between operations, between data personnel. So these, and essentially the idea is from the start, it's not a plug-and-play system. You build a laboratory based on your process, or that represents your process, and that requires some input from a handful of players in the company. And then from that standpoint, you have this digital twin that's always accessible. So it's a bit of time and investment cost to set it up, but once it's running, it expands from there. So I'm going to just click through. Let me wait. I need to stop sharing my screen. How do I do this? There we go. So I'm going to show you the app, Apromore itself. I've been logged out. Classic. Oh, okay. I'm just going to click through and show you a few examples so you can get a feel for the app itself. Now I'm just going to have to ask for your patience. I try to open these tabs all in advance because over Teams calls, the streaming is a little bit slow. But luckily, the data that we're going to be looking at isn't massive. And while we wait for that to load, I'm going to share this link in the chat. This is our company website with on a specific page dedicated to process intelligence. We've got two demos. One is covering the data that I've been discussing. One is for a different use case in Apromore, which we're not covering today. It's called conformance checking. It's basically how you can detect fraud risk patterns and that sort of thing. I invite you to have a look at these. These demos, if you are curious about understanding a little bit more detail how Apromore works. Okay. You know what they say, if it's a live demo, something is gonna go wrong. So I just need to restart Apromore. Hang on.
That's okay. In the meantime, if anyone has any questions, feel free to drop them in the chat, or right now as we wait, you can also just ask directly. It happens all the time, Dion. So totally understand.
Yeah, the real world is messy. Okay, so you can see Apremore has got a very nice navigatable system. It's just files and folders essentially. We'll go to this one. So you can upload a CSV. This is not yet the Salesforce integration. You can also upload XES and Parquet formats. The main thing is to get the data structure correct. So I'll just quickly show you what the data structure looks like. As I mentioned, there's the case ID, which organizes this information. The three main fields are case ID, activity, and timestamp, preferably start and end timestamp as well. Then role and resource are very important for simulation, especially role. And then beyond that, you would have all kinds of attributes that you can link to a case or an event. So another thing which is important is understanding the difference between a case attribute and an event attribute. A case attribute would apply obviously across an entire case, so this value would be duplicated. An event attribute, I don't think I have an example here, but obviously it would just be a singleton attribute within a case. So that's the structure, but very basically, of an event log. These data format, or they can get very complicated. So you upload it into Apremore. There's a nice little window where you can choose which fields need to be treated in such a way. You can anonymize data and all that kind of thing. I'm not going to go through the upload process now because I want to get to the interesting stuff. But it's always good to know how your data needs to be submitted to the platform.
I think what's interesting, I see it also takes format BPMN. There was a question at the last session that we had about exactly this, an interest of. So some organizations are starting with process intelligence, but they've spent years with BPMNs. How do they get started and so on? Can you just elaborate briefly, like how it works? So what happens? So you upload the BPMN, and how is it then converted into a data model or?
Yeah, so it's actually a lot simpler than that. You can start with BPMN in Apremore. But Apremore has made things much easier because they actually discover a BPM from your event log. So kind of works the other way around. And if you do work with large event logs, I would definitely suggest applying a GZ zip to it because it seriously reduces the file size. Or you can migrate to XES. So this is just telling me that it's discovered the schema that I've used in the past. You can apply that same schema, or you can start from scratch. So this is where you upload your data. It automatically discovers the main fields that it needs. You can obviously change that if necessary. Oops. It gives you a little preview. If you click on this, let's rather do a resource. If you click on that little icon, that will actually anonymize the data. So then produces pseudo labels essentially to cover up any real names. This is synthetic data, so that's not necessary, but it's an important aspect to consider. And then you upload it. It takes a little bit of time depending on how large the file size is. You open it up, and then the first point of landing really is this process map. And this, so essentially between event log to process map, Apremore does this automated discovery where it calculates and computes all the various statistics and parameters that it can about the given process based on a very fixed formal understanding of how process logic tends to work. So that's really one of the strengths, is this automated discovery. It makes process mining a lot simpler, and this really emphasizes Apremore's commitment to making process mining focused on analysts and business managers rather than highly technical people. I mean, you can add a lot to Apremore if you have the technical skills, but we don't want to set the barrier of entry too high either. So what this is showing that basic ticketing process. There's the activity assigned to cases. These numbers are currently showing just the case frequency. It's just a raw count. There's 1,000 cases in this synthetic data set. and those cases are grouped into about 283 case variants. So those are 283 instances of the process, which are somewhat repeatable. You can change these overlays to reflect the relative case frequency. We can also flip to duration. This is that figure we were looking at previously. I think, yes, we also have costing information. So you can add cost per hour for a given role. So that is how we compute costs. And then we can change the perspective. So because we have resource and role information, we can also visualize, we can change the process map to look at a different aspect of the process. These are the individual resources, and if we group them into roles, we can look at the role perspective of the process as well. And one thing which is quite nice, if you want to experiment a little bit with Apremore, when you upload, you can upload an attribute as a perspective event attribute, and then it'll appear at the bottom of this list, and then you can visualize it as well. But there are some data limitations there. So this is essentially how we can easily find where are process problems. You can apply filters to whittle down the process map, because often you have a massive amount of data in a process map at the moment, and it's showing, the full data set. So you would want to filter that down, highlight perhaps a particular problematic channel that you have in your process. So the filtering is quite extensive. I'm not going to go into too much detail, but essentially they're grouped in terms of case and event filters. If we apply a case filter now, so this will essentially, an event filter would keep only the activities that say match the event that you, or the attribute you've chosen. A case filter is a little bit different, so we can look at a case attribute, perhaps channel. You can see about 32% go through the call center, 33% through email. So let's look at only cases that come through email. Applies that filter, then we've got your set of filters appear here. You can then completely apply that filter, and you see the statistics do change. The general pattern is the same with these two major bottlenecks, but yeah. So that's a demonstration of some of the filtering capacity that the tool has. We can also build dashboards. So I've set up a dashboard beforehand that we can quickly look at. There's a fair amount of composability with regards to the kind of charts and figures that you can construct in these dashboards, but they're not. Yeah, it's very. I would say it's very constrained to process thinking, constrained to process logic. So everything is in terms of case attributes, that kind of thing. So Apremore does have a handful of dashboards out of the box, because they've structured their discovery in such a fixed manner. Just takes a little bit of time to load. There we go. So this will tell you, basic performance across time, how many activities are being done. You can see here that the majority of cases are resolved within 3 hours, but there's this long tail and a breakdown, etc., etc. So I'll just skip to the composable views. So this is a quick dashboard I built from the synthetic data. We can set up KPIs with very, very basic target representation. You can set up bar charts with any of these attribute data or case frequency data. There's also heat maps, which are very nice for example, resource handovers. So you can see a lot of cases are cycling through these agents, so they're handling a majority of the work. You can also then apply filters to these if you want to investigate particular process instances and that sort of thing. So there is dashboarding functionality. Now, let me get to the more interesting stuff. How you would change. Sorry, are there any questions before I move ahead? Let me just quickly check the room temperature. Okay, I assume that's no questions. So I'll just do a basic demonstration of how the simulation would work and then what the results mean. Let's do the technician assignment. So what you would do from this process map, you would abstract it to the level that you are, or that is applicable to answering your question. I'm just going to clear this filter. Hang on. Very important to clear filters before you start different work. So with this arc slider, you can really see the detail in a process, because the thing to understand is that these process maps, they are representations of the process. They aren't direct flow. If you want to see direct flow of a given case, you'll need to highlight a specific case to see how it proceeded step by step. So if I click on case 1, then you see this is exactly what happened in that case, nicely laid out in a sequence of events. But to show all the data at once, you have to make some concessions. So essentially, ARC controls that abstraction. So if we set it down to 3%, that's sort of where we were. I think its default is about 10%. So this all depends on how complex you want the simulation to be, but we'll keep it simple for now at about 10%. It's very simple to move from process map to BPMN. You literally just flip a switch, and then it automatically places the gateways that it discovers. If you increase the arcs, it finds more gateways. So it makes BPMN very accessible. From that point, you would then save BPMN model, and you would include the simulation parameters. So I'm not going to do that here. But that essentially then saves one of these little orange icons. The blue icons are the event logs. And then this would be, sorry, it's not loading now. Let's look at this one. So this is then the BPMN that was discovered from the process map, from the event log. And if you open up this tab, there's a whole bunch of simulation parameters. You can set time zones. You can set the inter-arrival time between cases. You can set how many cases you want the simulation to perform. If you click through these, you can actually set gateway probabilities. So if I click on reopened, I can also assign which roles handles that activity. You can set time activity distributions. These are the various distributions that we have support for in time units and that kind of thing. So what we would essentially do to perform a simulation is we would look at, for example, the assigned to technician case. The assigned to technician activity. And what Apromore was able to discover and automatically infer from the event log is that this activity follows an exponential activity distribution with an average of about 3.6 hours per activity, instance, and it's being performed by the technician role. So in the scenario that I discussed previously, the what if scenario, we could potentially automate this with an RPA bot. So the idea is we could maybe bring it down, instead of waiting 3 hours, we could bring it down to about 10 minutes. Just remember this is where the technicians would then get cases assigned to them based on whatever RPA solution you can devise. And so that 10 minutes becomes an important assumption that the analyst needs to make. So what you would do is you would then, first you would run the simulation based on the as-is model to get the baseline for comparison. Then you would save you would essentially save as and copy this BPMN over to a new file, and then you would edit things. So here, what I've done is I've kept the distribution the same because it's probably quite accurate given that it was discovered as that. But you can change it if you choose. I've set the mean down to 10 minutes as opposed to 3 hours. And obviously mean has different implications if it's an exponential or a normal distribution. So those are things that you need to be aware of. And then I've also changed the role. So what you have to do when you change roles, for example, you would have to first create a role. So there wasn't a bot role in the original, the as is BPN. So you simply add a role, and you would then say how many resources is provided to that role. You can assign the cost, you can assign a performance handicap, you can then assign the tasks to that role, etc., etc. So I've done that with this bot, and I've basically said that this bot is going to be now responsible for this activity instead of the technicians being responsible for it. You would then run the simulation, which the simulation essentially uses all of these discovered statistical parameters to then generate synthetic data. And what makes it interesting is that it's the data has been generated from statistical patterns which were inferred from the original process. So that's where the calibration and the as-is model step becomes very important. But I'm not going to delve into that information now. So then what you will do is you would take the as-is simulation, you check that box. We've got the automated technician assignment simulation that we've generated simulated data for. And then I'll just throw in this extra supervisor comparison. And then we would open up a new dashboard. While this is loading, I just need to attend to this. Sorry, my cat just knocked something over. All right, so then Apremore is quite smart. If you've created a dashboard from simulated data, it recognizes that that data has come from a simulation, and then creates a specific simulation dashboard. So what these charts show at the moment is case duration and case waiting time and case cost. We're going to focus on duration and cost for now. So you can see that the color coding is for the baseline. The blue is the baseline. The red is the technician assignment, so that's the one I sort of walked us. Green is for when you add an extra supervisor to deal with an unrelated process issue. So in actual fact, adding the supervisor, which is the green outcome, reduces the average case duration to about 5.5 days, whereas the case duration for the technician assignment only gets reduced to about 6 days. So if you really want to split hairs, the supervisor is actually the better option for reducing case duration, depending on what your goal is for process optimization. But as employing a supervisor is a lot more expensive than building a bot to handle an activity, there are cost implications. So if we look at the cost data, the automate technician assignment has a higher frequency of cases clustering in this low cost zone, whereas the supervisor is slightly more cases clustering slightly above that. So you can see the distribution essentially of these little bars, with obviously the as-is simulation being sort of in between the two, with not that many cases in the very, very cheap zone. We can look at the overall comparison as well. If you look at the case cost for the baseline scenario, that's about 1,500. With the RPA solution, you actually save a 500 Rand approximately per case. And then obviously with the case cost for the additional supervisor, it stays roughly in that 1,500 Rand zone. In fact, it increases ever so slightly. But because of the gains in process optimization, it does sort of pan out. So this is then where we will draw up a table and say, okay, well, what are the pros and cons of each solution, which gives us an outsized increase or outsized benefit in either costs or case duration compared to what is it we're actually trying to optimize for. And that's what I like to call the comparative return on investment. We can also look at things like resource utilization. I'm not going to go into too much detail about this, but this is essentially an audit of how much each role was used for a given what if scenario. So obviously the bot only exists in the scenario where the bot is there. There's no data in the as is where the bot doesn't exist. We can see the technician gets used a lot more in the what if scenario where the supervisor is involved, but gets used a lot less in the scenario where the automation of the technician assignment. So that's showing that gain of time and money that the RPA solution accounts for. The supervisor is a different story, more or less the same in terms of resource utilization, but that resource utilization obviously is, I could say, absorbed by the process. So that's Aprimo in a nutshell, with a nice little bit of clicking around demonstrating the app itself. I want to then move to the final stage of this presentation, which is going through a bit more of a complicated case study from a client of ours. So this is in the customer care space at a media company. So the bottom line is, we were contacted by this company to investigate the performance of their IVR process, which they self-report receives a lot of escalations, which end up costing them money. So a basic process investigation revealed that about 31% of calls are escalated to agents, and that those costs annualized are about 100 million rand a year. So the idea is that each call costs the company on average about 30 rand. So what potential process redesign or process changes could we implement to divert customer care flow to RPA or to IVR tooling rather than to human agents? So that really calls into question, what are these various customers trying to accomplish? And that adds a lot of complexity. The bottom line is we found 4 opportunities, kind of in the same spirit as the 2 opportunities that we discussed previously, although these are all 4 automation opportunities. And among those opportunities, we found 2 that seem to be the best for different reasons, and I'll go through what those are. So to build the event log, we took data for the session envelope, the back-end operations, and then the customer journey, the customer input itself, and we combined that with the CRM data, which accounts the actual escalations. We then put that through an ETL in Python, where we would normalize the activities, infer the role resource information, classify the outcomes, et cetera, to then produce this simulation-ready event log where the activities are time-stamped and they're case-wise, et cetera, just adding a lot of enrichment. We then analyzed that data, that process in Aprimo with the process mining, as I like to call it, diagnosis step, and then we used Aprimo again for digital twin simulation. So the findings, first of all, is that the escalations were highly concentrated. Of those 31% of cases, about 40% were related to technical error clearing, and there's this long tail. We decided to cut it off at the 6 process types carrying the most volume. And this is just a representation of the complexity. The whole IVR tooling process is on the top left here. The escalations are on the top right, which I've zoomed in on. The idea here is this is real very messy. These human agents are assisting customers with a lot of complicated information, which makes devising an automated solution quite tricky. So what we ended up having to do is we ended up having to really focus on a handful of relatively straightforward cases where the agents were only asked to perform one or maybe two actions, as opposed to the customer getting the agents, or the agents having by necessity to perform a whole range of interactions on that customer's account. So straight out the bat, we can rule out any automation what-if scenarios based on general information requests and the technical error clearing, just because they are hard to automate because they're more probabilistic than deterministic. So that leaves us with 4 general process types. And this is now getting towards the sort of 1-2% improvement range, which is realistic for the size of the client that we were dealing with. In the process optimization space, you're often dealing with mature processes. So if you can shave off 1 or 2% at a large organization, it does translate into quite significant costs. The other factor to consider, apart from these 4 scopings that we devised or discovered, is there's a range of activities, again, a long process tail, where many cases go through, for example, a package upgraded step and an agreement updated step. A handful of fewer cases which were focused on service package upgrades go through invoice updated or general information provided. So we used a cutoff of 15% case representation. So essentially, we only considered activities within these process types that occurred in more than 15% of cases. So if you look at the service reconnection, service reconnected was an activity that an agent performed or finalized in 25% of cases, agreement updated in 22% of cases, but again, general information provided was in 13% of cases. So we only considered these 2 activities as candidates for our what-if scenario to automate. So this is a slightly more simplified view of the streamlined cases that we found, and they represent about the 1 to 2% range of the escalated cohort of cases. What is interesting to note is that one of the opportunities discovered was customer profile update, and this ends up being quite a good option to pursue because the automation is quite simple. There's no agreement update. These other 3 scopings have agreement update as a human agent performed activity in more than 15% of the cases that it's escalated in. So that's a factor to consider, as the integration complexity, apart from the costs as well. So that's where we start talking more about that comparative return on investment. So broadly speaking, the method, as I have discussed previously, is we created an as-is BPMN model. We then calibrated it so that the costs, the activities associated with transferring calls to the agents cost out to about 30 Rand per case. We then created 4 BPNM scenarios where we modify those. We redesign the BPMN. We modify gateway probabilities in the different scenarios to represent RPA bot activity and that sort of thing. That's very complicated. I'm not going to go into that now, but essentially all you need to know is we started with one baseline and we tested 4 separate what-if scenarios. And as you can see, this is another cost. So the blue, again, is the as-is, so the baseline, with a high case frequency around that 27 to 35 Rand range. And the lowest case frequency in that region was the service package upgrades, and you can see that's actually the highest case frequency in this low cost bucket, bin. So definitely the highest savings, the highest of the 4 scenarios that we scoped, the greatest savings are to be sought in improving the service package upgrade route. And this is based on essentially what is the actual customer throughput in the process based on real data. So if you annualize that information, you can see that service package upgrade definitely gets the greatest savings, about 1.5%. Then we have a sort of a tie for the middle. So customer profile update and service activation are kind of moderate cost savings approaches, where service reconnection really falls by the wayside. So we can at this stage already say, okay, we can toss that one out the window, and we don't have to worry. We don't have to put any time or effort into planning any service reconnection upgrades. So if we put this on a comparative ROI chart where we've got cost reduction on the x-axis and automation complexity on the y-axis, the high return on investment zone is this bottom right corner. So obviously service package upgrade, because we can predict that the cost savings based on the throughput will be the highest, gets flagged in the high ROI zone. And also the customer profile update might not have the highest cost savings, but because of its lower build complexity, we only had to simulate automating one activity as opposed to 2 activities. So that makes that makes it a good candidate for like a case study or a proof of concept. So that's essentially where we went afterwards. We would either validate the data, or we build a prototype on either of the 2 solutions. Then we can run a pilot, scale the pilot, and then we can also use Aprimo monitoring and dashboards to build KPIs to see if these changes are actually having an effect. So that sort of speaks to that round trip process mining. So that's the case study based on some real world data. That's a little bit more complicated. I wanted to take us through the foundations of process mining and digital twin simulation, a very scoped, very basic implementation of how that works, and then a show of how it looks like in the real world. So now is the time to open up the floor for questions.
Yes, there were no questions in the chat, but just talking to your last slide where you showed the kind of like the plan on how a typical use case would be developed. I know there were questions before about how much time does it take to get to first results or first insights in your typical use engagements or use cases that you've worked on?
Yeah, so I mean, that's an interesting question. I'm going to respond kind of cheekily by saying, how long is a piece of string? It all depends on how ready. It all depends on how ready the data environment is. A POC can take 3 to 9 months, depending on the complexity of the work. That's why it's very important to have the different players involved from the get-go. But I would say if the data environment is ready and accessible, maybe it can take you 2 weeks to a month to really build out the ETL correctly. And then the actual process investigation may take another week. So you're looking at maximum 2 months if you're going to be really thorough. But obviously, I'm sure that's my pace. I like to work slowly so that my brain has time to process things. I'm sure there's some very smart people out there that will work a lot faster than I will.
Are there any other questions from the round? Otherwise, we can close then the meeting. We will be in touch as always. We will share. We will have the recording. We'll also do a post. The little man misses me already. We'll also do a post where we'll share some links for you about where you can get started. There were also questions around are there any online training courses by Apromo. So all those things we can also share in the wrap up email and also in the post, right? So look out for that. Just say to everyone.
Yeah, so
Yeah.
yeah, your child is bothering you and my cat is bothering me. This is how it goes.
Just on time, yeah. Thank you so much, everyone. So keep an eye out then for the wrap-up email, but also the post on LinkedIn with all relevant links. If you still have any questions, feel free to post in the chat. Otherwise, also when we send you the email, feel free to follow up also with the team from SIBA in case you want to get started or you want to do a POC, to try out anything. Also reach out. I encourage that you reach out to the team. Perfect. Then thank you so much and have a lovely
Thank
evening,
you.
everyone.
Thank you. Bye.
Awesome.
Bye.
Thank you,
Thanks.
everybody.
Bye.
Bye.